everyone, I'm Lisa. I have a question for you. Does light have its own color? Well, I think that's an interesting question. I mean, when we think of light, we're usually thinking of the type of light that we can see, which is visible light. The reason you can see me is because there is visible light that is reflecting colors and shapes off of me and into your eyes. The light on me and around me is showing all different kinds of colors. But could it have one true color, separate from all the other colors we could see? Well, unfortunately, probably not. I mean, even if light did have its own color, separate from all other colors, we would most likely never be able to actually see it. Why? Because color itself is basically an illusion that's made up by our eyes and brains. An innate illusion, meaning that colors we can see or can't see come naturally to us. We're born with them. Color is created by very tiny and special cells at the back of our eyes. They are called cones. Now, most people have about 6 to 7 million cones in their eyes. These cones are located on a very tiny spot on our eyes called the fovea centralis, which is on the retina. Now, these cones are responsible for detecting different colors of light. They can usually detect 3 different colors: red, green, and blue. When these cones detect light and are activated, they send a signal to the brain. The brain then assesses how many cones were activated and the strength of their signal. After all this is processed, the brain decides on what color is being reflected back at you, and therefore what color you are seeing. Now, most of us can naturally see colors and tell other colors apart. I say most of us because not all humans see the same colors as everyone else. Some people can't see certain colors, and some can't even see colors at all. And still, some can't even see light at all. Now, what about light? What is it? And what does it have to do with colors? Well, a quick overview about what light is. In science class, particularly astronomy class, we learn that light is a form of electromagnetic radiation and is a part of the electromagnetic spectrum. Light is made up of tiny little particles called photons that, when heated up, travel in a wave-like pattern called a wavelength. Now, as mentioned earlier, visible light is a part of the electromagnetic spectrum. Specifically, visible light is the only part of the spectrum that we can physically see, hence the term visible. The part that we can see is actually a pretty narrow part of the spectrum. We can usually see from about 400 to 700 nanometers, give or take about 100 nanometers. A nanometer, by the way, is a very small unit used to measure length. Its length is only 1/billionth of a meter, way too small for our eyes to see without having special microscopes. For instance, a single strand of human hair is about 80,000 to 100,000 nanometers wide. That is small. Okay, so what about the rest of the spectrum? Well, the rest of the spectrum contains forms of light we actually cannot see. They're called radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Now, how come we can't just see these light forms with our own naked eyes? Why do we need special tools in order to not only detect them, but to actually see them? Well, because unfortunately, our eyes' innate ability to detect light and color is actually quite limited. Every one of these other lights is literally invisible to our naked eyes. And that's because they travel in wavelengths that range from being too long for us to see to being too short for us to see. Therefore, we need special instruments like radios and spectrometers in order to both detect and see them. For instance, radio waves have the longest wavelengths on the spectrum, while gamma rays have the shortest. Now, visible light lands in about the middle of the spectrum in terms of wavelengths. And on that note, color itself also travels in wavelengths. For example, the color red has the longest color wavelength, while indigo and violet have the shortest. However, all of these different forms of light have to somehow fall into the colorful visible spectrum for our eyes to detect them. Wait a minute, what about white light? Couldn't white light technically be considered the true color of light? And why would it? Well, because the appearance of white light to our eyes is actually the combination and reflection of all the colors in the rainbow. When something appears white to us, it's basically just how our eyes detect it. Now, there are some devices that we can use to divide white light into all the colors of the rainbow. For example, the white light being dispersed into all the colors of the rainbow with a prism demonstration. You've probably seen this many times before. As you can see, this beam of white light is being divided by the prism into all the colors of the rainbow, as well as their different wavelengths. Now, using a prism to divide white light into different colors was first demonstrated by Sir Isaac Newton in the 1660s. Now notice how the color black is not among the colors. That's because the color black is the absence and/or complete absorption of all the colors. It does not reflect or emit any light. For instance, the shirt I'm wearing. The reason it looks black to me and to all of you is because it is absorbing all the colors of the rainbow right now as we speak. And it's also not reflecting any back out and not really any light either. So it gets to look black to all of us. And it doesn't get to be in the rainbow. Now remember when I said that not all humans see the same colors as everyone else? Well, what do I mean by that? How can two people look at the same thing and see completely different colors? Well, this common perceptual phenomenon was really exposed and made real to a lot of people in 2015. A single photograph divided millions of people around the world because they couldn't decide on what its colors were. What am I talking about? The dress. Yes, the dress. In 2015, this dress, made by Roman originals, became a huge viral internet sensation, not because of its amazing design, I mean it is a really beautiful dress, but because people, believe it or not, could not decide on what its colors were. Now millions of people all over the world, on Facebook, Twitter, Tumblr, Pinterest, Instagram, you name it, were arguing over just what colors this dress had. I mean, people argued with their family members, their friends, coworkers, and complete strangers, mainly on social media. While millions of people saw the dress as blue and black, just about as many people saw the dress as white and gold. And therefore, the main argument was which colors were the dress, black and blue or white and gold. I personally saw it as black and blue, while my mom saw it as white and gold. And some people didn't even see the dress as those colors. Some saw it as velvet and pink. What's going on here? Even celebrities got in on the debate, and some even saw it as completely different colors. It was so popular that it even became a Halloween costume that year. Now, Roman originals did eventually come out and confirm the dress to in fact be black and blue. Ha! I won that argument, Mom. So that's Lisa 24, Mom 533. I'm catching up to her. Family argument bragging rights aside, because so many people saw the dress as white and gold, there was a white and gold version of the dress that was made by Roman originals and was auctioned off at a charity. There are several theories and explanations as to why so many people saw the dress as blue and black and white and gold and many different other colors. One being the different photoreceptors that people have in their eyes, which are also the rods and cones, and how they skew light differently than other people. For instance, if light skews one way, a person could see an object as black and blue. For the person standing next to them, light could skew a completely different way, and they could see that very same object as white and gold. Another explanation is what's called color constancy. That's basically where our eyes just basically assign certain colors to objects under many different lighting conditions. A lot of what made the dress's colors so controversial was the lighting in the photograph itself. Some people couldn't tell if the background was bright and the dress was in the shadow, and others couldn't tell if the whole room was light and the colors on the dress were washed out. So, many different people picked up on the different visual cues in the photograph, which really helped with the confusion, basically. For people that saw it as white and gold, their brains were actually working a little bit harder to make it look white and gold to them, and once it was white and gold to them, they couldn't see it as anything else. Basically, not until the dress itself was shown in its full black and blue glory that people were like, really? That is black and blue? I'm colorblind, apparently. And people that saw it as black and blue, their brains were not working as hard, and they were not confused at all by any of the lighting on any of the photograph. While it's been known for some time that humans perceive light and color differently than animals, it really is astonishing just to how different light and color are perceived by humans between each other. It really is. I mean, it really just goes to show how differently we are made, how often people perceive colors differently from other people. So, what's my point in all this? If light really does have its own color, more likely than not all of us would see it the same way. I could see it as one color, and you could see it as a completely different color. And color really is made up inside our heads. So, yeah, if light really does have its own unique color, away from all other colors, we would probably not be able to detect it, even with special instruments. Even if we could, as was proven by the dress, we would probably not be able to decide on what shade it was, or even what color it was. That's a bummer. Still though, I think it's cool to think of those kinds of possibilities in our universe. You know, thinking of things that most people would probably never think of in their entire lives. What do you think? Do you have any ideas and or questions about the universe that might seem out there? Let me know in the comments. I hope you enjoyed this little presentation, and if you'd like to know more about the topics covered, please feel free to check the links in the description below. If you'd like to be notified about upcoming videos answering uncommon universe questions, please feel free to subscribe. A special thank you to my Beanie Baby Bunny Cotton and to my black shirt for helping in this demonstration. And thank you all so much for watching, and we'll see you next time.